So this is my second session here, and I'm very excited. Very pleased to see a lot of familiar faces. Uh, so what I'm going to do today is expand on what we talked about last time. Last time we talked a little bit about building data products. We talked about the data lifecycle. Today we're going to expand on that thought and talk about building MLOps strategy. Now, MLOps is not specifically about building a model. It's about once you have a baseline model, how do I productionize the model? So we'll talk about what it means. And there is a lot of rationale behind this topic, at least when I have personally gone into a lot of projects, a lot of clients, they keep telling me a fact. They say, oh, you know what? We do have 50 data scientists in our team. Last 1.5 years, we have not been able to industrialize one single model, even with 50 data scientists. The problem is not specifically around building models. Sometimes the problem is industrializing those models. And today we'll talk about the patterns, the capabilities, the steps that are needed to productionize a model. So in a typical sense, productionizing a model has 6 phases. It's again a representation, a typical representation. It starts with a initiation phase. Somebody has a business requirement, somebody has a use case in mind, and that's somebody's typical business. And it goes into a project onboarding process. Onboarding means tapping back into what we talked about last time, getting the right data, getting access to the right data products, getting access to the right tools and technologies, and then starting with the POC phase. Proving a value to the business, saying with a limited amount of funding, with a limited amount of capability, there is a proof of concept that probably has an opportunity for growth. Then you go into an MVP phase and say, yes, the business is happy with the POC. Let's try to convert this into something more tangible, more scalable, and finally you industrialize it. So there are 6 steps typically that starts with an idea and ends with an industrialization phase. Now, to achieve these 6 phases, there are some key processes and key outcomes. The key outcomes are typically your gatekeepers. It can be your gatekeepers, it can be your checklist, but there are some key processes allowing you to have some key outcomes, and the key outcomes become the actual important thing for moving into your next phase. So for example, for the first case, you talk about having a business alignment. Business says, oh, we have a big challenge with churn. So we want the data science team to work with us and figure out a way of identifying people who are churning. We as data scientists or as the people who will be onboarding into the project will go and understand the problem and do some feasibility study. As a company, do we have enough data points? As a company, is that, or from a business point of view, is that requirement really tangible? And then you align the stakeholders who are in play, who needs what, and it's not about building the model, it's about building the outcome, which means somebody might say, oh, we just need a report in Excel. At the end of the model, you build that Excel report and send it on a weekly basis. So somehow you have to have your stakeholders in mind and come up with a strategy that says, what is the end goal? The end goal is not to deploy the model. The end goal is to get the prediction to the right people. You start by getting the seed funding, right? So seed funding, or all the fundings that we're going to talk about right now, it's a representation. Sometimes it might not be funding. Sometimes it can be as simple as a checklist, somebody manually going and approving. Similarly, you have onboarding process. So it's very important. It ties back to what we talked about last time. This is all about getting the environments ready. How do I get access to my data products? Do I have an access to the data catalog? Can I search and discover my data? Can I get a data quality report to understand if the data is really good enough for me to start building my model? So all of this is about getting readiness to your building that idea into something more tangible. And what you do is you start creating a playground environment where you have access to production data. Now, the key word here is production data. We are starting to get only into the project onboarding and into a POC phase, but we are still talking about production data. Why? Now, a traditional approach to building model was I'll build model with some mock-up data or some dev data. But in an actual world, when we talk about big data projects, when you talk about big companies, invariably there will not be development data. And if you start cooking up some data, you're not going to production use your model with your time in mind, right? So you have to get access to your production data so that the models that you're building, the POC outcomes that you're creating, these are not technical POCs. You're not creating value out of technology, you're getting value out of the business, which means we do not have access to the POC data. There is no way for the business to understand whether the outcome is good or bad, right? So this is something that we are trying to encourage our clients, our customers to understand that, hey, even though we are talking about a POC, getting access to the data is not about getting access to the cooked up data. It is about getting access to the right data, which is production data.
Sorry, I have two questions. One, what does POC stand for?
Proof of concept.
Oh, sure. Okay. And the other one is, so even with the cost of dealing with figuring this stuff up, even at this phase, this early on, this session?
That's true, yeah. But again, you can decouple it. Last time we talked about data mesh, so you can have a decentralized and federated way. So let's say we are talking about finance, right? So the finance as an organizational unit can have a data science team and can have a data engineering. The data engineering team could have given or gotten you the data like pretty clean and curated. So we talked about the bronze, silver, and gold zone last time, right? So your data is, ideally cleansed up. You have your pristine data. As a data scientist, you're evaluating whether that pristine data is good enough. You still need to do a lot of pre-processing and post-processing, but you should have some basic standards or some kind of profiles and reports that you can measure the quality of the data. Next, what you do is you start with a POC. And the important thing about POC is we do not want to spend 6 months in a POC. So your seed funding is important. You have a very small runway. You have your guardrails in place. You know what exactly needs to be outcome. So what you do is you use libraries. Typically, a lot of our clients will say, oh, this is the place where we'll do a lot of auto ML. I'm not going to go ahead and start building my machine learning algorithms, tuning the algorithms or finding the best model, not yet. I'm going to find out with some low code, minimalistic approach, something that provides an outcome that the business is happy about. And once you do that, you get an OPAX funding. You get the funding that you need to actually start hardening your algorithms. And that is where you start building your code, converting your, let's say, Jupyter notebooks into Python classes. You start building your more intuitive model building, training, hyperparameter optimization. You start connecting your models with all the bells and whistles like feature store, model registry. You do all kinds of fairness evaluation of the model. All of this is going to be in the MVP phase, right? MVP is minimal viable product. You're creating a product which is minimally viable. And then you get a CapEx funding, which is like, I'm going to get you funding for run and support, less productionize. That's where you get the ARB approval. So ARB is architecture review board. So within the organization, when you productionize something, there has to be some kind of an approval. You get the approval, you onboard the right team. So far, the team was very data science heavy. Now you have to slowly transition your work to, let's say, somebody like a data engineering team or an ML engineering team, because you as a data science team would go into a new project, right? You'll have a new idea in mind. You'll try to prove out that idea, and you want to give that run and support, that hypercare to a more industrialized team. Team will be taking care of productionizing it, right? And then eventually you do the PI planning, and then you deploy the model as a product. So again, deploying model as a product is important. A lot of our clients are deploying models as projects, which means they'll think of this as a project. They'll run this model as a project, which means a team is always in place, working on the project, doing the project life cycle, and there is very less collaboration between that team and the learning to another project person. So when you think of ML as a product, you think of it in two angles. One, deploying the model is not the end game. The end game is about getting the outcome to the right stakeholders. And two, now it's a product. I deliver a product, I move on to create another product. I'm not actually just sitting ahead and working on a project. And now, how do I do that, right? How do I go ahead and start building the entire solution? So typically a 6-step process. You start by building the data foundation. We talked about the data foundation last time. 2 is you set up the actual experimentation platform. So this is where, how do I get access to production data? How do I ensure that I do not have, more access than I should? For example, the data, when you talk about production data, your PII, your guardrails, what you can or cannot access, all comes into picture. So how do I ensure that I get access to the production data with the right guardrails, with the right processes in place? Then how do I have exploratory analysis and pre-processing of the data? What tools and technologies I can use? How do I build and validate the model? How do I operationalize the model, like deploy it? And eventually, how do I govern the model, right? So that becomes a 6-step maturity process. So typically, at least from my perspective, when I go and talk to the clients, again, most of the clients are not starting from zero, right? They will have some kind of capability, some kind of footprint in their ML journey. So for me, it's important to go and talk to the clients and understand their maturity. So these 6 steps, evolve into something like this. So we take our customers to a journey of tier 0 to tier 5. Tier 0 is proof of value. So as a part of the proof of value, we say, okay, no, we want to understand how mature are you. We think that at least in tier 0, you should have these capabilities enabled. You should have your data sourcing enabled. You should have your feature engineering and feature selection enabled. You should have visualization and statistical data analysis capability enabled. You should have your model selection, model training, model tuning, some kind of an interactive notebook and scheduler, right? So these are the capabilities you should have at the minimum. And customers might say, yeah, we have most of it. So, all right, that means you have what it needs to create a proof of value. If not, then we'll again work with the clients, customers, and then build these building blocks, right? So we'll work with them and say, okay, let us help you, work on a scheduler so that you can go and build this, schedule your model deployment, or let us help you bring in a package that can help you with some visualization and easy ways, right? So this becomes your, tier 0. Tier 1 is the process foundation. So once you have the tier 0, can I enable our customers with tier 1? Tier 1 is all about the enterprise data platform. Can I connect you with the enterprise data, the production data? Can I start with the harmonization of the data? Can I enable you with any kind of data integration and automation? Can I help you with model selection? Can I help you with business rules and value, validations? So all of these are capabilities that we are assessing our customers with. And then if we see that there are some gaps, then we recommend that these are the capabilities we can enable them with. So it not only becomes a process guide for us, it also becomes capability guide. And these capabilities can be now more tangibly built. So if the client say, oh, I do not have something for traffic monitoring. And traffic monitoring is, oh, I've deployed a model in production. I do not know how much of traffic is going in there, right? At what point of time I'm getting more requests for, let's say, if it is an online predictive model. I do not know what time of the day I'm getting more hits for prediction. I do not know which areas, what geography, what demography this data is coming from, right? So if the client says, well, we do not know traffic monitoring pattern, then we can build something for them. Because once you have something, for example, the traffic monitoring, you can have the feedback loop. You can understand who is accessing what, who is requesting for what kind of prediction outcomes, and that can feed back into your next set of training cycle. Then we have commercialization. This is more about getting your MVP, getting geared towards production IP. You're talking about labeling, categorization. You talk about enabling your feature store, because this is the time when you have a very solid set of features. You've identified what features are needed for your machine learning model. And now you can collaborate. You can say, oh, these are the feature sets that I can register so that others can use from it. And then you talk about the continuous learning. So continuous learning is all about ensuring that I'm capturing the model store, model in the model store, the metadata in the metadata store. You can interact with the models, you can evaluate the models. You can have artifact registry so that you can put all your artifacts into a common repository and registry.
So at this point, everything's fully like in band, and you have like automatic data integration already rolling, like completely, right?
Yes.
Okay, yeah.
So again, this tier 0, tier 1, tier 2, tier 3, these are all maturity assessment. And it's not about maturity assessment just theoretically. It's about the building blocks that enable those customers, right? So that it's very easy for the customer to say, hey, you know what, this particular capability I might not have. That's a gray area for me, right? So if it's a gray area for the customer, we can actually start talking about, what it takes to build this particular component for our customer. So that becomes very easy to understand what are their gaps, what is their maturity, And for those gaps, what can we build and how to build it, right? So that becomes easy discussion with the customers. Same democratization. So it's very important that we are not spending 6 months of research cycle for every single model. It's very important that you. So again, from a corporate perspective, it's a question of build versus buy. What is my tangibility? What is my value for money? And in that case, this is where we talk about citizen data scientists. We talk about tools and technologies that are available today. For example, something like Data IQ. Data IQ is a tool which is more visually intuitive, which means it is easier for somebody to pick up that skill and build a model that represents something. So at this stage, we're talking about let's not keep that knowledge to a group of 20 data scientists. As an organization, you need to have data scientists, at least 150 data scientists understanding the business problem and creating something more meaningful. So which means at this point of time, we're talking about building those democratization capabilities, talking about how do we enable people who understands data to be not limited by technology. You need a core group of data scientists, but you also need more democratized capability so that your value, your speed to market is improved. And finally, the full scale ML, that's where everything comes back together. And we say, oh, based on the 6 capabilities, all the building blocks are done. This is where we think you have attained your maturity, and you can now continue maintaining this as a life cycle. So what we talked about till now was we talked about that every MLOps process goes through the initialization phase to your industrialization phase, 6 phases. We talked about how we eventually go and assess people on their maturity. Next, let's talk about what are the capabilities with them. Right? So broadly, we talked about data implementation. We talked about model implementation. We talked about productionization or industrialization and governance. So what we on my team focuses on is to build those assets and products, which means based on this assessment gaps, we have created these key capabilities and said, what if we build modules around this? And if we can package this as a module, then we can provide this to our customers saying, this is what you need for your data implementation. Once you've done that, these are the things you need for your model implementation. These are the things you need for your productionization. These are the things you need for your model governance. So some things around model governance would be, how do I explain the model outcome? Right? Somebody says, oh, I'm not going to give, my model says I'm not going to give you a loan. Question is, why not? Right? So mostly in financial organizations, you'll be asked the questions like, why am I not given? Why is the machine learning predicting something that it is predicting? Can you explain the reason? So you need to talk about the model explainability. What if analysis means in case my SSN or in case my, let's say my credit score is a little bit more, will it change the outcome? So what if analysis, right? Audit and traceability. Can I audit the reason? Can I come back after 3 weeks and say, oh, I had this kind of a requirement. Can I come back and understand why it was predicted that way? And then risk management. How do I mitigate the risk? So again, if we look into these are nothing different from what we saw in the last slides, but this is all about capabilities, right? So for model productionization, I should have ability to evaluate the model. I should have the ability to do change management, catalog management, model validations, drift detection, model deployment, and all of those things. So I'm not going to bring the slide, but this is where I'm going to talk. I have a small demo today again. What I'm going to do is we're going to talk about how this becomes the centerpiece of converting ideas into tangible, reusable modules and assets. Questions? So let's look into a flow, right? So how is the end-to-end flow looking like? So we talked about piecemeals, we talked about certain capabilities. What is the entire MLOps flow? You start by the 4 engineering principles. You onboard the data, you do your metadata capture, ingest the data, create profiles, standardize and curate the data, things that we talked about last week. Once you do that, the byproduct of building your data lake, building your data mesh, building your data products the right way, the byproduct of that is you get the centralized catalog. And the centralized catalog eventually becomes your data marketplace. I can now go into that marketplace and search for a data set. I can say, hey, where can I find my customer data? And they will say, the customer data is located in this particular location. This is the profile report, this is the data quality report, and so forth, right? So building the data foundation in the right way allows me to create a byproduct, which is a feature store, which is the marketplace. And that marketplace allows data scientists to go and search for the actual data sets that are important. Then as a data scientist, you'll say, okay, I will go ahead and I'm going to build my model. So I'm going to go through a process, and I said, I shall register my experiment. I can start my experiment. So I'll get access to all the tools and technology, and I can get started. I can start getting access to the data. So at this point of time, with proper permission, proper roles, proper capability, I can connect to the marketplace and I can start getting access to the right data sets. Once done, I can start with the experimentation. So I have my ideas. I'll try with all different algorithms, different kinds of tuning and hyperparameterization, all the algorithms. And every time I do that, I go through the same cycle of preparation, feature engineering, filling test score, model evaluation. And every time I do that, I'll create some artifacts. I'll create a model outcome, which I can store and version in my model repository. And every single time I've created a list of features that I will use, I can put them into a central feature store. So in a typical engagement, you do not build a feature or you do not build an algorithm one time, right? You probably have gone through a phase of 50 experimentations. You might have experimented with the same idea with 20 times with an XGBoost, 20 times with a live GVM, 10 times with something else. Within those 10 times of XGBoost, you might have defined different kinds of hyperparameters. So you have done a lot of experimentation, you have changed a lot of parameters, you have gone through a different set of groups to find out the model that resonates. And every time you do that, it's important to register those experiments into the model registry. So again, the byproduct of building a process like this is to ensure that as a data scientist, none of my work is going to waste. If I have an idea, if I'm creating a particular experiment, I'm actually auditing this experiment so that after 50 experiments, for example, I realize that experiment number 49 was really the one that has low bias, that was actually resonating with business outcomes. So what I do is I go into the feature store and the model repository and say, oh, I can package that particular model and then deploy it into production. So that way, it becomes easier to now read your model, get your model from a model repository and publish that into your higher environment like QA or production. So the next few slides, what I'm going to talk about is I'm going to deep dive into some of these capabilities, and then we'll spend a little bit more time on the demo. Okay. Now this is the slide we saw last time. Again, just to level set. So this one talks about enabling the database, which means, as an example, somebody said, I have a product data in SFTP, and I have an RDBMS data in my, I have an order data in my RDBMS. My business requirement is to predict, forecast which products are going to order more for next month, right? So this is a business case. Business came to you with the requirement, and the requirement is to create a forecasting model. So step one for the engineering team would be to onboard the data. And we talked about it last time, but onboarding the data should go through certain hoops. So for example, you start by onboarding the data into raw. You run your rules engine, data quality engine, standardization processes, reconciliations, consolidations, match and merge, put the data into curated. You do the same thing for the order data, and then you start joining the data, you create that data product, and you publish the data product, right? So it goes to the hoops where these are the bare minimum steps to convert your external data into something more meaningful, which has a single purpose. And the purpose of that data set would be to create a forecasting model. Now, this is what a typical, onboarding for a data science project would look like. So now I've created a model. Next step is, now I've created a data product. My next step is, as a data scientist, I can go and search for the data sets. And do I have a data set that has product information and order information? So again, byproduct of creating that pipeline was I created a data marketplace And because I have a marketplace, the data scientist now can onboard the data using self-service capability. He can perform data wrangling, data processing, data curation. He can define the data quality monitor. He can look into the data profile and statistics, and he can start exploring the data. He can analyze the data and say, oh, is my data good enough? Is my data normally, following a normal distribution? If my data has some outliers, you go ahead and start doing the feature importance. Now, are there certain features that are important? Are there certain features that are not important? I can take it out. You can do the entire life cycle and go from a data product into something tangible, where you have selected a series of features and say, okay, I have 200 attributes in my data product, but I think for this model, I probably just need 120 attributes, right? So you go through that loop and understand which are the 120 attributes, for example, which are more important for that particular use case. So once you go into that feature selection and importance, you start with that and you say, okay, now I can actually build my algorithms. So you do some, model tuning, you can start building your model. Every time you build your model, you should register that experiment into a model, into a experiment registration process. And then you should also capture your metadata. You should also capture your traceability capability. You should create a model catalog. And once you go through the loop where you've got the data, you start building an experiment, you register the experiment and metadata, you created a model catalog, and finally, you start comparing those models. So I created an XGBoost with, let's say, a few parameters. I created another version of the XGBoost with another parameters. I should have the ability to compare the models. When I say compare the models, because I captured metadata, because I have the scores of the model, it's easier for me to evaluate, which model is performing better, right? So once you do that, you submit your model and say, okay, this particular experiment that I did with all the metadata that I captured, I'm sending it to an approver to approve it so that he can evaluate it. He can be a senior data scientist, or he can be a part of your architecture review board. But he said, all right, I'm going to look into your model metadata and I'm going to make a decision whether I can productionize the model. So once you do that, you start converting all the experiments into actual tangible code, right? So we talk about that as a code hardening capability. I might have done my experimentation using Jupyter Notebook. Now it is time for me to convert those into something like, a Python class, right? Something similar, I might have just deployed everything in my dev environment, just out of manually, and now I can do my Jenkins integration. So all of that can happen in the ML engineering section. And once you do that ML engineering process, you can actually deploy the model, have your data scientists evaluate the model, bring in the actual, business people and understand whether this makes sense. And again, in this example, we're talking about ML flow. I'm not sure if you're aware of ML flow, but ML flow has become a gold standard for model evaluation. It's become a gold standard for model registration. It has become a gold standard for all this model metadata capture and comparison. So, you can integrate with something like that, and then you can start evaluating, approving, packaging, deploying, integrating the actual model with the Git repository or Bitbucket. You can actually integrate that with your data catalog and model catalog. And then once you deploy, evaluate, once the evaluation is done, let's say this was done in a QA environment, you can repeat the same steps for your production. Now, this is a simple question. It's a simple slide that talks about, from a Databricks perspective, what it means to build a production-ready model. Now, we talked about all of this previously, right? So we talked about you need to have your data. You need to have your exploratory analysis capability. You need to build your model. You need to have some kind of auto ML capability. You should have some kind of a model tuning and model comparison capability. You should have some kind of model registration, tracking, and monitoring capability. You should have ability to integrate your outcomes into a feature store, all the features that you selected. You should have an ability to serve your model, either as a batch model or a real-time model. And you should be able to explain the fairness and the outcome of the model to some of the libraries. So again, this is a representation of what we have built through Databricks, where we say, okay, we use Databricks as our ML platform. We are interacting with all these right capabilities, third parties, open source tools if needed be. And then we are out creating this entire, initialization to productionization process through a list of these capabilities, which has become much more tangible. I have one last slide before I jump into the demo. So this slide talks about, actually one last slide before that. This slide talks about, as a data scientist, we have done our work. We have taken into consideration all those boxes that we talked about. Now the question here is, are we ready for productionization? So there are certain key players and there are certain questions that we typically ask, right? Why this is important, why talking about the key roles are important, because your experimentation, your discovery, your model building can be done primarily by data scientists, but your industrialization needs multiple teams. Right? So it will need data engineering team. So you need to ask the right questions to the data engineering team. Now, have we identified the data sets? Are the data sets available? What is the process of getting the data into the data lake? Are there access control and security measures all taken care of, right? Then you talk about the ML engineering team. The ML engineering team is all about the people who will be hardening your code, ideally, and then eventually they are the people who will be putting the model and then performing run support on the model, right? So you ask them questions around, I gave you the code. Have you converted that into right Python libraries or artifacts? Have you created your ML pipelines? Have you integrated those pipelines so that I know the frequency of my data refresh? Now I know how frequently my model has to be refreshed. Have you enabled model governance? Have you enabled model matrices and metadata capture? Right? So these are the questions you ask and say, show me that we are ready to be productionized. Then you talk to the data science team. So by this time, the data science team has already given us that model, which means we're not asking them whether you have built the model. We're asking them, can you validate the model? We have converted your Jupyter notebook into production-ready code. We've attached all the bells and whistles to the code in terms of integrating with feature store, integrating with model registry and whatnot. Now, can we evaluate? Can you help us build those test cases? Because you have built your model with some baseline in mind. When you talk about the MLOps team, right? Have I integrated that with a CI/CD pipeline? Do I have automated build scripts to Jenkins pipeline, right? And then you talk to the business team and say, okay, can you define the test scenarios? Can you validate the outcome that we're creating? And finally, the platform team, where to save the data, where to read the data from. Do I have the right authority and capabilities? Where is my production environment? Where is my dev environment, right? So all of this becomes important question. So this slide, anchors the outcome to define that as an MLOps industrialization process, it's about the right teams, the right, ability to have capabilities defined, and the right kind of responsibilities. So once you have all of that, you're ready to productionize your model at scale. At scale means in a more automated way, in a more repeatable way, in a more governed way. So with that, maybe I'll just skip into the demo. So you can still see the screen, right? All right. So this is the tool, me and my team we were creating, we have seen this is mostly used for the data part. I'll just give you a quick, maybe 2-3 minutes of update on what it was. So this tool was primarily created for onboarding and building your data products. It internally creates Spark jobs. The Spark jobs can be deployed in AWS and Databricks. It allows you to onboard your data with all the bells and whistles we talked about, right? We talked about rules engine, data quality engine, STM engine. We talked about ETL engine. All of that becomes easy. So I'm going to start the journey saying, as a data scientist, I have identified some key data sets I'm coming here and I say, okay, I'm going to build a pipeline. And in that pipeline, I'm going to read some data. So in the example, we talked about reading, let's say, product data, and I can read another order data. I can apply any kind of curation. So I can do some deduping for the data, right? So it becomes pretty, easy, drag and drop, low code, no code approach. I can join my data. And finally, I can write my data. And once I write my data, which means I have been able to get my pristine data sets, I've been able to apply some business logic and create a wide table. Now, what I can do is to ensure that this particular outcome is available for model building, I can register this as a feature set or a feature store. So from a Databricks perspective, I can say, okay, the data that I've created, I'm going to register this as a feature set. So when I register this as a feature set, all the schema, all the details about the data is registered. So it becomes a repeatable and reusable capability for a data scientist to search for the data set, search for the feature set, and start building his model, right? So I can actually also do a lot of things in terms of, typically you will see a lot of functional requirements, like, how do I backfill missing values? Or can I do some lookups? Or can I do some kind of pre-processing of the data, right? So you convert your data into one-hot encoding, standard scalar, all the good things, right? So you can drag and drop and you can build that connected to, right, in somewhere in the middle. So at this point of time, from a data perspective, I've been able to identify the data sets, apply some business logic, convert the data into a more ML capability, and finally save the model, save the data output as a feature set. Now, this feature set is something I can use, for example, in Databricks. So I go into Databricks and I say, all right, this is the example. We have a framework, and in the framework, we have some common libraries, we have some projects, and we'll talk about the wiki, right? So let's say I have 3 examples here. So this is where, to a customer, we will give them all the common libraries, we'll give them all the UIs, we'll give them all the capabilities and say, okay, now you have the ability and all the boxes assembled to start building the data, ML model. So in this case, let's say the client says, okay, I have a use case in mind, and I'll start with my alpha phase. Or actually, I can start with my exploration phase. I want to explore my data. So what we are trying to do is we are trying to build those reusable capabilities. So in this case, somebody will say, oh, this is my location of my feature set. And if I load the data, I automatically get interactive capability to understand how the data is distributed, right? So for each of the data sets, I can look into the distribution of the data. I can see how the data was segmented, how the data is distributed. So it gives you an exploratory way without writing code to analyze the data. Then you can also do what-if analysis. You can say, oh, this is my data. If I order the data by age and understand the annual income, I want to understand how the annual income is evaluated, right? So what is the trend? So again, this is where, with the minimum amount of seed funding we talked about, you can analyze the data, evaluate the data without writing code. You can actually go ahead and say, okay, these are the findings I have got from the data. Similarly, you can have detailed profile report. So how many variables are there? How is this distributed? Is there a high correlation in the data set? Are there some, how is the data distributed? For each of these columns, you'll get all the spread. So again, these have become toolkits. Yeah, this has become toolkits to measure, analyze, evaluate, and even come up with the right kind of columns, right? Why I say right kind of columns? Because by looking into this data visually, you might say, oh, you know what? These 2 columns doesn't make sense. So you can go back to your data processing. You can change your algorithm a little bit. You can update a new version of your data. And without actually writing code, you come here and again, analyze the data, and you end up finding that right data features, right? You say, okay, I started with 200 features. Some of the features were highly correlated. Some of the features had too many null values. Some of the features were like totally, not associated with what we are trying to figure out. So by going through an iterative visual process, pre-built, pre-baked packages, I've come up with a list of features that I can use for my next step, which is my model building.
So, but at this point, I want to make sure I'm not coming, at this point, the target user for this thing is still the data science team, right? Not the customer. Okay.
Yeah. Yes. So as a data scientist, with the seed funding, without actually having to write the code, with minimal turnover, like, somebody says, oh, I want to check the feasibility and I want to find out what matters. So within 1 week, you can go get the right data set. You can quickly tune up this data, the data workflow in this case, and eventually come here and say, okay, this is what I need, right? These are the features that I want. Next step, what you can do is you can say, okay, I want to do my alpha testing. So remember, alpha testing was where, I can do at the minimum some kind of auto ML, right? So I'm not spending a lot of time, but I'm doing some model building. So I come in here, it again goes to the same loop, you understand, analyze the data, and then what you can do is, again through packages, you pre-process some data and you evaluate the data and get some fairness, right? So when you define the fairness of an algorithm or a data set, fairness can be measured in multiple ways. Some places where the fairness can be measured is exploratory fairness. Exploratory fairness means I can ask the question. I can say, oh, genre is important to me. That is a protected column. And typically, privileged value of the column is something that you expect to have more, right? So male are, in this case, protected. I want to ensure that this is a mall expenditure, right? So this use case. So I'm trying to see what are the factors to determine who spends more in a mall, right? So again, I'm asking the question, like, if I'm getting the outcome, is it biased? Is it biased? So I'm trying to ask the question to the data, asking, if male is the prevalent value of gender, then can I evaluate whether spending, so here the spending is evaluated between 0 and 100, right? So greater than 50, tell me whether the data is uniformly distributed or not, right? So here in this case, it tells me that, this is 51%, which is 0. 0 means female and 1 male's mean because of the privileged and non-privileged. And seems that the data is not biased, right? So again, these are toolkits capabilities where you can ask questions before you start building the model. You can do exploratory biasness and fairness test of the data. So to ensure that if the data is highly skewed, if the data is already very skewed, if I train it, the data is, the outcomes are definitely going to be skewed, right? So you need to start asking these questions before you start modeling, so that in case a particular data is highly skewed, you can start going and building synthetic data, right? So there are multiple ways of training a data set that is biased. What you can do is you can take away some data, so for example, fraud detection. Typically, a fraud will be 1%, right? So even if I build a model that says not a fraud, the model will be 99% accurate, right? But that is not the right measure of the data, right? So in that case, you need to understand the fairness. You need to ask the questions. So one way of mitigating that would be to create some synthetic data. And the synthetic data should have the same kind of data characteristics to that underprivileged data set, right? So here, in case you found that the data was skewed towards a particular segment, you can create some synthetic data, and then you can start building your auto ML, right? So in this case, the auto ML gives you a list of all the algorithms, gives you adjusted R square, and MSE. So you can evaluate and say, oh, you know what? I think LGM regression model is the one that performs the best for me. So I can go ahead, talk to my business, give them an output, and if they are giving me a green signal, then I can actually go and build a model which is a light GBM model. And that model, if I can tune, instead of getting it out of the bat, if I can tune it, that model is ready for productionization, right? So that becomes a way of algorithm selection as well, right? And it gives you some of this information, and then you start building your auto classification. You are getting some scores. You can evaluate the scores. You can getting some predictions, and you're saving all of that into ML flow. We'll talk about ML flow in a bit. Question?
Oh, no, sorry.
Right.
It was a question about those two values not adding up to 1. It's clear.
Yeah.
I would have a question, like, how do you convince customers or clients that they should invest in all the nice things at the end, while they already have, or they ask for it after you basically have an MVP, maybe one step further. Right, because that's when you get the features, that's when you get the insights, but then obviously for the long term, like smaller improvements, you want to do all the steps afterwards. But I think it's hard to always convey that to other people.
Excellent question. And that is a problem that a lot of our customers are facing. It's a real life problem. So question was, we end up in an MVP and the MVP satisfies customers' demands. How do you convince the customer that you need to industrialize it, right? And it's an actual, problem in industry because, a lot of clients I'm working with, they're stuck in that MVP cycle for a long time. They're not moving outside that MVP cycle because the business doesn't see a lot of value out of it, right? They're saying, oh, what is the value of me getting into enabling feature store or, building an automated test scripts or building automated Jenkins, right? So the process is all about guardrails. If you can have right kind of guardrails in your dev environment and say, oh, I can deploy the model for testing, but there is no auto refresh. Or I can get the output in your MVP, but there is no run and support team. Tomorrow, if something goes wrong, there is no SLA, right? So these are things that you can enforce, create those guardrails to ensure that, there is a path after MVP. Otherwise, you're right, business doesn't care how, elegant your solution is, as long as the outcome is elegant. And that way, you need to have the right guardrails, and the guardrails will ensure that, you're not creating what we call it as a shadow IT. You're not creating a small group of team who are on an ad hoc basis, looking into looking up for the MVP project, right? So the transition from MVP to productionization is all about the money one, but it's also about the guardrails. So if you can have the right guardrails in place, projects will be, or the business will be forced to make a decision sooner than later, right?
Could you elaborate a little bit on what an example of these guardrails would be?
Yeah. So a simple example can be, a model can be, the model needs to have a live endpoint, right? For example, you build a model and you need the model to be deployed as an API because somebody needs to ask questions on it, periodically. What you can do in the MVP is you deploy that as a batch process, right? As a batch model, which means we are not responsible for creating that API. We have deployed the model. The model runs once in a day or once in a week, and the business has validated it. But then the business cannot get what they want because the model is not deployed as an API. That conversion to the API can be done maybe something as a part of your industrialization. So that is one example where the model solves the business problem, but the business needs something more, and that something more is not available in the MVP stage, right? You cannot have an API because once you deploy an API, you need to have the security and all the tokens in the APIs, right? So you do not enable that in the lower environment. So that is one example. Same with beta, right? So now you have created an AutoML, you identified from an AutoML what is important, which models, which algorithms are looking good, and it goes through the same process, looks to the same capability, and you say, okay, now I'm going to go and build my model on my own. I've created my models. The models are going to give you some features, which features are important to you, which are not important to you. So apparently age, right? So we were asking the question, which factor helps you understand who spends the most in a mall, right? And the answer here, at least in this model, is age, which sounds pretty okay. And the second one is the income, right? If you are in a particular age group and if you have a particular income, you tend to spend more in the mall, right? It's not about you being male and female, right? So again, the data was not biased that we evaluated. So similarly, if you can go in, this is the explainability. What explains, right? What is explaining you the outcome? And this is again something called SHAP library. So you can evaluate and say, okay, I have made some outcomes, and now this outcome is giving me, so blue means what is making that prediction up, red means down, right? So you can look into this and say, okay, these are the characteristics that can explain to me why that person is spending more or why this person is not spending more, right? And you can still have some fairness evaluation, some density plots, and then you can say, okay, everything is done. It's very fair. I can go ahead and start registering the model. And where did we register the model? The model was registered into something called MLflow. So as a data scientist, my job is done. I have created an algorithm, I've evaluated my outcome, and I've actually registered the model into a model repository. Let me show you the model repository as an MLflow, right? So this is the model repository. Every time I have run something, it creates an entry. It's an audit trail. I can open this and I can evaluate. Let's say this one, right? We have some sklearn ones. Let's say this one, right? Yeah. So this is the sklearn model. So this model we have registered. Now, because of all the metadata that we have captured, you can look into it, right? So all the metadata is available here. All the matrices that we captured is available here. All the artifacts, right? What is my ROC? What is my recall? Everything is captured here. And the model itself is captured here as a zip file, right? And what I can also do is I can, like I said, I can evaluate these models. I've done multiple iterations. I can actually compare the model and say, okay, show me between these two models, which one is better. So it gives me an indication of which models are better, and then I can make a decision and say, oh, you know what? The second model looks good. I need to register this. So what you can do is you can come back here, go to your model and say, I want to register the models. This is where you are now packaging the model, right? So once you package the model, you can again come back, go into your testing, and you can actually go ahead and hook up to your registered model. And then once the model is deployed, you can ask the question like, this is my data, tell me the new prediction on the unseen data, right? So this is just an example of a framework where you start with gathering the data. So you start by identifying the key data elements, building the data pipelines, register the data as a feature set. You go through the feature set, we analyze the data. Without writing a lot of code, you statistically evaluate the data. You can go back and reevaluate your data pipeline. You go back again, find your features. Once your features are done, you can start with your alpha build, where you do a lot of auto ML. You do your fairness testing. You evaluate your data. You evaluate your model. You talk to the business, and they say, okay, good enough. Then you build your beta product, where you go find from the auto ML, you find the right model. You build your model, you tune your model, you add all the bells and whistles like model registry feature set. Then you can run that particular process. It creates an entry into the feature store. It creates an entry into the model repository. Go into the model repository. You can compare multiple experiments and then register the model that is important to you. And once the model is registered, you deploy and you can start asking questions. Again, just a representation. There are multiple ways of doing something like this, but this is just an example of a typical framework that allows our customers to start with understanding the data all the way to deploy the model and start asking questions. So with that, I will conclude today's slides that I have. But again, I'm sure you'll have some questions.
Does it also give insight about like how this scaling would happen eventually, right? Use scale and also provide something around that. Does this platform provide something like that?
Yeah, not entirely on this platform, but then there are others. So this is something we talked about. You might have missed it, right? So, so this is where eventually you talk about the industrialization. And there's something called a business and an ARB, right? ARB approval is all about, architecture review board. So once you have your model registered, you have started asking questions, you have to take it to your, actually get more funding for it, find the teams, right? Because now you have done it as a data scientist. For productionization, you have to start talking to, data engineers, MLOps team, platform team, right? So that's where you need to do your PI planning. And then you have to find the release date. You have to have the right team, and then you can start deploying this product.
Same question about, do you think in the industry like, there is a quite distinction between all those teams that you mentioned, or like sometimes like there's a lot of overlap being expected in terms of roles and responsibilities? Maybe it's a startup or maybe it's a big tech company. Like how do you feel those kind of roles divided, and how as a data scientist you need to also work around the other roles simultaneously, right? Because we expect that the ideal roles and responsibilities should be the way that we shown in the last paper. But what do you think about the current scenario and like how it is evolving?
It's a great question. So again, the maturity is highly scattered, right? The projects, teams, organizations who do not have that many number of people. But one thing is important, right? I mean, even if one person can have multiple hats, it's important to have those roles, right? So I can play the role of a data scientist. I can also play the role of an ML engineer, right? But the role should be there. And you can actually physicalize the roles by converting those roles with something like, typically from an AWS perspective, we talk about IAM policies, right? We talk about SSO integration. So, you should still have those roles in the organization in your Active Directory, but it is possible that, for smaller organizations, the person has 4 roles, right? This is possible. So yeah, personally, as personnel, it might differ, but the rules should, I think it should be there.
If anybody has any other questions to send through the chat, please feel free to do so. We've gotten a lot of thank yous for the very detailed presentation and demonstration of MLOps communication. This is amazing. Thank you.
Yeah.
Does anybody else have any questions? Okay, great.
Can you talk about the timelines for all these stuff? Like where is most time spent usually, where are the least time spent?
Yeah, actually, I have one slide that I didn't want to talk about a lot, but this is a process, right? Again, so every project we go into, we start with a gap assessment, right? Because invariably, every project has some kind of a footprint. So the gap assessment is important. And based on the gap assessment, we talked about tiering, right? We talked about these tiers. So that's where, we try to first go into a 4 to 6 weeks engagement, analyze what is available, what is not available. And then the estimate is based on those gaps, right? But let's say somebody says, oh, we have nothing, right? So typically nothing means, do you have data maturity at least? If you have data maturity, then creating an ML maturity would be at the minimum 6 months to 8 months project. But then again, it's very unlikely that somebody would have 0 ML presence in the organization, right? So a gap analysis and assessment becomes very critical. Good question.
We're getting lots of thanks from our participants saying that they're working in MLOps. This is very helpful.
Thank you.